Hi class, this is lecture 30 for Econ 4001.02 and I'm your professor John Raybeck, so let's get started. This lecture is going to cover when firms set prices and we're going to focus on the monopoly case. So here firms will be setting prices by deciding how much they produce, and we're going to assume that the demand side everyone will buy at that given price. So this will be a situation of monopoly. So in this situation, we have a single firm who has complete control over the production of a good. And here, we're also going to assume that the firm has perfect knowledge of the demand function, right? So they're going to know exactly what the consumer demand is in the market. And here, the demand function will enter the problem through inverse demand. And this is going to be given by some function that we're going to say is P of y, right? So it's the price at output y, and this is just given by the inverse demand. Right, so for the monopoly problem then, a firm is going to solve the following. So they're going to maximize their profit, but here the price is a function of how much that they produce. So again, we're assuming that however much is produced is going to get consumed according to the demand function, which is encoded here in the inverse demand function. And production of goods here will directly affect the equilibrium prices. So we can just look at the first order conditions for this. And again, this is essentially an unconstrained problem since we just have this y is greater than or equal to 0. So if you ever have some amount of output that's less than 0, then you know that the firm is producing 0. So here we can look at the first order conditions. We're going to denote derivatives just by this prime since these are univariate functions. So we'll have p prime of y, which is the derivative of price times y, plus the price of y minus the derivative of cost is equal to 0, right? So this is just our first order conditions. We can rearrange this. So this first part right here is a marginal revenue. So this is the additional revenue that a firm gets by producing an additional unit. And this is the cost, right? So we can rearrange this and we'll get marginal revenue is equal to marginal cost. Right, so this is the same kind of condition we used to solve the situation where the firm wasn't a monopolist, except there the price was fixed. So the marginal revenue per unit produced is just given by P, whereas here the marginal revenue is given by this more complicated term. The derivative of P at y times y plus the price of the good at the amount of output, y. Technically, we also need a second order condition to hold in order for this to be a maximum. So this condition here is just local concavity, right? So concave functions are those whose second derivatives are negative or weakly negative, sorry. So this is just the condition that these are the maximum. So one way to guarantee this is that, the cost function is concave. It is going to be a good step in that direction. The cost function is convex, because if the cost function is convex, then this second derivative of the cost function is going to be greater than 0, and then the negative of that will be strictly less than 0. And then that will be times these other features, right? So this is needed for the production to be optimal for a monopolist. One other thing we can do is we can relate the first order conditions to elasticity, right? So remember, elasticity is this measure of a percentage change of quantity, change in quantity divided by a percentage change in price. Right, so it's essentially how much quantity changes as price changes. And we had these different regions of elastic, inelastic, and perfectly elastic. So how do these relate to elasticity? Well, if we look at the marginal revenue condition, we can pull out this price of y. And if we do so, we'll get that marginal revenue is equal to the price, so the inverse demand function, times 1 plus 1 over the elasticity epsilon. And just for a reminder, here epsilon is the elasticity, so it's the change in quantity over change in price, times price over quantity. And this can also be written as this way, as in terms of the inverse demand instead, right? So here D is the demand function, or market demand function, and capital P is the inverse demand function. So one thing to note is that demand is normally downward sloping, so epsilon is normally negative. Great. So for most problems, monopolist will produce in the elastic region, so that the elasticity needs to be less than -1. And this means that 1 over epsilon is greater than -1. And this occurs since when epsilon is inelastic, the marginal revenue is going to be negative, right? And remember, the condition we need in order to get optimality is that the marginal revenue is going to be essentially positive because we think our marginal costs are going to be increasing as we produce more things, right? So this is why I say for most problems, the monopolist will produce in the elastic region. And if marginal revenue is negative, then marginal revenue plus marginal cost is negative, and that would mean that you wouldn't want to produce anything. There's another way to relate the monopoly to monopoly pricing to elasticity. So one way to do this is through this notion of markup pricing, right? So if a firm has some market power, what they might do is they might try and increase the price of the good by some factor. And here, if epsilon is less than -1, this is going to be a term that's it's going to be, greater than 0 and, it's going to be between 0 and 1, right? So this thing will increase the prices by a scale factor that depends on the elasticity, and it's going to be multiplied by the marginal cost. So this isn't just coming out of nowhere, but it's going to increase the price of the good relative to the cost of the firm. So this is a way that we might expect the monopolist to make more profit. So normal pricing, remember, for a perfectly competitive firm is marginal cost is equal to price. Here prices are marked up instead by the elasticity of demand, right? So this P of Y star is going to be the pricing under the monopoly level, and this is marked up by marginal costs. So marginal cost multiplied by the scale factor depending on the elasticity of demand. Great, so I have an example here where the inverse demand function is given by this 10 minus y, the cost function is given by 1/2 y squared, and we want to solve the problem for the monopolist. So if we do this, first we want to set up the maximization problem. So this is going to be max 10 minus y times y minus 1/2 y squared. Right, so this here is the inverse demand function. And then again, we're going to have this restriction y is greater than or equal to 0, but we're not going to worry about it too much for this section. So looking at the first order condition, we get 10 minus 2y minus y equals 0. So if we just rearrange this and solve, we're going to get 10 thirds is equal to the optimal output. And then we can also find the price for the monopoly by plugging this into the inverse demand. So here the price is going to be 10 minus 10 thirds. So this is the monopoly price, and this is the monopoly quantity. So again, it's just solving an optimization. You can ask different things about this as well, like how much profit does the firm make and compare it to a price competitive firm at given prices. But again, that's a little bit too much detail for what we're going to be covering this semester. Great. So that's the end of this lecture. We discussed the monopoly problem, and we also discussed the relation of prices and elasticity for the monopoly problem. Great. Thanks for listening, and I'll see you next time.